Welcome back everyone, Patrick here, moving on to another word problem dealing with quadratics. This one's going to be fairly tricky. So we're told that a road splits into three tunnels that have the same height that form the parabolas below. So we have this road here, let's say you're driving down the road, and then there's one of three tunnels that you can go in, right? And each of these tunnels here, they form parabolas, and notice we're given some characteristics of them. So notice that this one, for example, is 80 meters wide. This tunnel is 60 meters wide. This one's 60 meters wide. And we're told that all of them have the same height, and the height is over here. It's 36 meters. So this tunnel is 36 meters, this one 36, that one 36 as well. Then we're told that the maximum point of the middle tunnel, so the middle tunnel, which is here, this maximum point is placed on the y-axis. And with that, we have to find an equation for each of these parabolas, for each of these tunnels, with valid x values for each as well. So notice that in this particular case, we can let the ground over here be the x-axis. And then we're told the y-axis is where this maximum point is. So we can draw a y-axis like that. And then from there, because we have an x-axis, because we have a y-axis, right? The y-axis is going to represent the height of the tunnel. And then the x values are going to be the distance from the center of that middle tunnel. So here, that's going to have a distance right there, or over here, that's going to have a distance over here from this, this middle part of the middle tunnel, right? The axis of symmetry that splits that middle tunnel into two. And so now that we have everything on an actual graph, what we can do is we can find the equation because we can create coordinates for each of these. So that's the first thing I'm going to do. I'm going to create some coordinates over here because we have enough information to do so. And what I'm going to do is I'm actually going to create coordinates for all of the maximum points. So over here, and then over here. And then I'm also going to create coordinates for these intercepts over here, these ends of the tunnel. And notice that like this end of the tunnel also represents the beginning of this tunnel, and then the end of this tunnel represents the beginning of this one, and then we have the end of this. So what I'm going to do is I'm going to find actual coordinates for all of those points over here. I feel like the easiest one to start with is this one over here because we know it's going to be on the y-axis, so we know that the x value is going to be 0. Now what's the y value going to be? Well, it's going to be the height of the tunnel, and we know that the height of each of these is 36 meters. So we know that this point here is going to be at 0 and 36. That's going to be the vertex of this parabola over here. And then we can move out. So notice that we're told that this middle tunnel, it's 80 meters wide. Well, notice that over here, we're splitting it in half. Right? So this here is going to be an x value of 0, meaning that because we're splitting the 80 in half, we know that this distance from the middle, over here from this y-axis to this point, is going to be 40 meters. And then same thing over here, the distance from this point to that axis is going to be 40 because it has to be symmetrical. The whole thing was 80, so now we just split it up into two 40s. And because we know the distance from here to here is 40, well, we know that this has to have an x value of 40, right? And then what is the y value going to be? Well, notice it's on the x-axis, so the y value is actually going to be 0. Notice that this here, it's an x-intercept. Now, what we're doing is we are letting the y-axis in this case be the height, right, in meters. And so the height from the ground at this point is 0, right? So that's where that h value is 0, but the distance from that middle is 40. Now what about this point over here? Well, notice we're going the opposite way, right? If this is 0, over here would be positive 40. Well, if we go this way, this point is going to have a coordinate of negative 40 and 0, like that. All right, and then we could just keep moving out. So same thing here. Notice that this tunnel, it's 60 meters wide, and then we're dealing with this maximum point here. So what we can do, like we did over here, is instead of looking at this entire width of 60, we could split it up over here, and we could say that just this is going to be 30, and then this width is going to be 30. So from there, that's enough information to get the coordinate of this point over here, because notice that if this is an x value, if this point is an x value of 40, well, if we add 30, then we know that this here is going to have an x value of what? It's going to have an x value of 70, right? 40 plus 30 gives us 70. We know that the height is still 36, so we know that this coordinate is going to be at 70 and 36, like that. And then to get this coordinate, all we do is we add another 30 to this 70, so we know this coordinate is going to have an x value of 100, and then the y value, or the h value, the height, is going to be 0. We could have also got the x value here because we knew the entire width is 60, so we could have just did 40 plus 60 to get 100, right? But I split it up in order to get the x value of that coordinate, to get the x value of the maximum of that right tunnel. Okay, and then going back this way, same thing. So instead of doing this full 60, well, we could actually use this full 60 to get the coordinate of this over here. Notice negative 40 minus 60 would give us negative 100. And then we're going to have an h value 0, right, because it's on the ground, so the height above the ground is 0. And then this over here, again, this 60 we can split up into 30 and then 30. So negative 40 minus 30 would give us an x value of negative 70. And then the height is the same for all three tunnels. So we know that the height of that maximum point of the left tunnel is going to be 36. And now we have enough information, because notice that we are given the coordinates of each of the vertices, and then we're also given coordinates of points on those parabolas. We're given enough information to find the equations of each of these parabolas, because we've done questions before where we were given the vertex of a parabola and then a point on the parabola, and we know how to find the equation. Right? We've done a bunch of questions like that, and it just becomes a question like that in this case. So what you want to do is you want to try to take a word problem, make sense of it in your head, and then just make it an abstract question. So what we can do is, if we want to just forget about this diagram and just create an abstract equation. So let's start with this left tunnel. Let's write out some characteristics that we have of it. Well, we have a vertex at what? Negative 70 and 36. And then we also have 2 points we can use for this parabola over here. We actually only need one of the points to solve for that a value in vertex form, which is what we're going to do. And whether we use this point or we use this point, it would give us that same a value. But for now, I'm going to actually just write both points. So one of them is negative 100 and 0, and then the other point is negative 40 and 0. Right, so this parabola here, it has a vertex of negative 70 and 36, and then it also has points of negative 100 and 0, negative 40 and 0. And we're going to have to use one of them to solve for that a value in the vertex form. Remember this and this, that's going to be the h and k value in the vertex form. But we will get there. Now, one thing that the question also asks for is the valid values of x, because notice that this is an actual word problem, and so we're not just dealing with a parabola that's going to continue to extend infinitely, right? This is not an abstract parabola. Notice that this parabola, it's only limited to this portion over here. And so the valid x values, let's actually write the valid x values that this parabola can take, according to this word problem, is between -100 and -40. So the x values have to be greater than or equal to -100, less than or equal to -40. That's what this parabola in this scenario is limited to. And then this one's going to be from -40 to 40. This one's going to be from 40 to 100. So that's what they mean by those valid x values, and that's why we wanted to find these coordinates over here as well, so we can know what each of these parabolas are limited to, what x values they're limited to. All right, so that is this left tunnel over here. Now, what about the middle tunnel? What are the characteristics? So we got a vertex at 0 and 36, and then we have 2 points we can use. We got -40 and 0, which is actually the same as that point, because remember, the beginning of this tunnel represents the end of this left tunnel, right? The end of the left tunnel represents the beginning of the middle tunnel. And then we got this other point, 40 and 0. And then what are the valid x values of the middle tunnel? Well, notice that the x values have to be between -40 and +40. Okay, because if we don't state that, then these are just going to continue to extend, and then it's not going to make sense for the word problem. And then finally, the right tunnel. What are the characteristics of it? Well, we got a vertex at 70 and 36. We got points, +40 and 0. Notice the same as over here. The beginning of the right tunnel represents the end of the middle tunnel, so they share that point. And then we also have the point 100 and 0. And then for the right tunnel, what are the valid x values? Well, notice that the x values can be between 40 and 100. Right, so we would say the valid x values greater than or equal to 40, less than or equal to 100, like that. And so now all we got to do is we got to take the characteristics of each of these 3 tunnels and then find the equations. So let's start off with the left tunnel. Now, again, just in general, what we're going to be doing is putting these in vertex form, because notice that we're given the vertex for each of these. And so that's nice, because remember, when we have a quadratic or a parabola in vertex form, the vertex is just the h and the k value. So if we're given the vertex, then we automatically get the h and the k value that we could plug in here. And then we could just use one of the points to solve for the a value. So starting with the left tunnel, we're going to have, and in this case, let's use h instead of y to represent the height. So we'll have h equals a, x minus -70. So that ends up being x plus 70 squared plus 36, right? We're using this vertex over here, and this vertex, the h value is -70, so x minus -70 is x plus 70. We've gone through that a bunch of times. And then the k value is just 36. And now what we got to do is solve for this a value. And again, we can use either of these points and we're going to get the same a value. So for this first tunnel, for the left tunnel, I'll show you how you can use both points to get the same a value. But then for the other two, I'll use one of the points. But if you want to use the second point for the other two, just to test it out, you can also do that. But just to save time, I'm only going to use both points for the left tunnel to show you how we can get the same a value. So let's start off with the negative 100. So we'll have 0, which we'll plug in for h, then we'll have a, then we'll have a negative 100 plus 70, that's going to be squared, plus 36. Okay, we're plugging in negative 100 and 0, that point, negative 100 and 0. And so what would happen, we bring the 36 over, so we'll have 0 minus 36, and then over here we'll have a, negative 100 plus 70 would give us negative 30, and then that's going to be squared like that. Then over here we'll have negative 36, and then negative 30 to the power 2 gives us 900. And so we'd end up with negative 36 equals 900a, like that. Then to get the a value by itself, divide both sides by 900. This cancels out, and then you'll have negative 36 over 900. So notice that we can simplify this. So notice we can divide this by 9. We could also divide this by 9, so we'd have negative 4 over 100. And then notice negative 4 over 100, that simplifies to negative 1 over 25, like that. So what I'll do is I'll actually take this a value and then I'll write it on the side. So we're going to see if we get the same a value with this other point, negative 40 and 0. Now sometimes this won't be a fraction, it could also be a decimal. Negative 1 divided by 25 is also negative 0.04. Right? So sometimes you'll see the a value in decimal format or in fraction format. Okay, but that's the a value that we get with that point. Now what if we, let's erase all of this, and what if we use the point negative 40 and 0 instead? So notice this is going to be 0, this now is going to be negative 40. And hopefully at this point you could tell it's going to be the same thing. We bring the 36 over, negative 36. And now over here, negative 40 plus 70 would give us positive 30. And then that's going to be squared. So before we had negative 30, now it's positive 30. But because we're squaring it, we're still going to end up with that 900. And we're still going to have negative 36 on the left side. So the a value is going to be negative 36 over 900, which again, it's going to simplify to negative 1 over 25. Or in decimals, negative 0.04. So notice whichever point we use, we get that same a value. And that's going to be the same thing for each of these. No matter which of these points you use to solve for the a value, you're going to get the same a value. Another thing I want to mention is notice that the a value is negative, which makes sense because remember from the diagram, all of the parabolas, they are pointing down. So we're dealing with the left tunnel was pointing down, so it makes sense that we get a negative a value. Okay, so we have now the equation. So the equation, I'll write it over here, for that left tunnel is h equals, let's use the decimal. But you could put a fraction here as well, doesn't matter. So we'll have x plus 70 squared plus 36, like that. All right, so for the left tunnel, that's the equation. Those are the valid x values where this parabola is drawn. And then if you also get the time, maybe on a test, if you really want to make sure this is right, what you could do is you could test out those points. So you could plug in negative 100 here, or you could plug in negative 40 for the x value. And when you do all that algebra on the right side, you should get an h value of 0 if you want to be If you just want 100%, make sure that you're getting the right equation. But that is the right equation. All right, and so now we just have to follow the same process for the middle and the right tunnel. So let's start off over here with the middle. So notice that the vertex is 0 and 36. So what we'll have is x minus 0 squared plus 36. Now x minus 0 is just x to the power 2. So this equation, it's actually just going to be in this format over here. It's going to be in that ax squared plus c format. And we've gone through this format before. I mentioned in previous videos, whenever a parabola, any parabola is in this format where that bx is not there in the middle, right? It's just ax squared plus c. The vertex is always going to be on the y-axis. Okay, the vertex is always going to have an x value of 0, right? Which, notice in this case, that is true. And so now we just have to solve for this a value. Again, you can use either of these points. It does not matter. You can use the negative 40 and 0, or you can use the 40 and 0. Actually, in this case, it's easy to see that whether we plug in negative 40 for the x or positive 40 for the x, because we're going to square it, we're going to end up with that 1,600 over here. Right, so let's just use negative 40 and 0. So we'll have 0, which is h. Then we'll plug in negative 40 for x. Then we'll have plus 36. Bring the 36 over. 0 minus 36 gives us negative 36. This is 1,600a. Divide both sides by 1,600 like that. And so we'd end up with negative 36 over 1,600. That's what the a value is going to be. And then you could simplify this fraction here. So we can divide this by 4. We could divide this by 4. And we'd end up with an a value of negative 9 over 400. All right, and then that right there does not simplify. So the a value in this case, it's either negative 9 over 400, or if you want to get the decimal, you can divide that in your calculator. You'd end up with negative 0.0225, like that. So either of those a values that you plug here would work for the equation. Okay, so that's the middle tunnel. I'm going to use the, I'm just going to stick with decimals for all of these, but again, you can use fractions. Maybe a question like this, your textbook may use fractions. So just make sure that you're able to get both of them. And then we'll have bracket. Actually, there is no bracket. It's just an x squared by itself because the x value is 0 of the vertex. So it's like x minus 0 in that bracket, which is just x squared. And then we got the plus 36. All right, so that's the equation right there of the middle tunnel and then the valid x values. This parabola, it's only drawn for those x values to represent that middle tunnel. And then finally, the right tunnel. Again, same process. So we're given the vertex, so we'll have h equals a x minus 70 squared plus 36, like that. And then I actually think the a value is going to be the same for this one as the left tunnel. It's only the vertex that is going to be different. So we could plug in either of those points, 40 or 100. So notice if we plug in 40 here, we'll end up with negative 30 to the power 2. That's going to be positive 900. Or if we plug in 100 here, 100 minus 70 is going to be positive 30 to the power 2 is going to give us 900. And then that 0 is the same for h. So again, doesn't matter which point you're going to use. I'll use the 40 and 0, bring the 36 over. You'll end up with 900 over here. So like the left tunnel, the a value is actually the same. It ends up being negative 36 over 900, which simplifies to negative 1 over 25. So the a value is negative 1 over 25, or negative 0.04. Okay, so the equation for the right tunnel is going to be h equals negative 0.04 x minus 70 squared plus 36, and the valid x values are between 40 and 100 for that right tunnel. All right, and that's it for the question. So hopefully you understood that. It's when you first get it and you get a diagram like that, it looks complicated, but once you break it down, right, you put the y-axis in and then you get the coordinates, all the coordinates that you need for all three parabolas, then it just becomes one of those questions where you have to find the equation of a parabola given a vertex and then given another point. And then you could also use the diagram, you could use those intercepts to find the valid x values for each parabola.